to this talk. Actually, before I go ahead, can we show hands? How many of you have done reactive already? Done reactive already? How many of you are still thinking or wondering? Okay, great. I'm Emily Jiang. I work for IBM. I'm a senior technical staff member in IBM. I'm the Liberty microservice architect. Anybody are using Liberty? Heard of IBM Open Liberty? Okay, cool. So basically, in this talk, I will focus on the reactive microservices. I will share my journey from imperative programmer to be a reactive programmer. So hopefully, I will put you into my take you through my 1-year journey. I completed from the synchronous coder to be the reactive coder. So it's share my understanding, share what I have learned in my journey. So hopefully by the end of this session, you will understand all the buzzword about reactive. When people talk about reactive, you know what they are after. And also, reactive is not for everybody. It's not for all the scenarios. You have to make a decision when you need reactive, and etc. Okay, I will put in the 3 sections: why, and what, and how. Oh. Since earlier I mentioned I came from an imperative programming background. What do I mean about imperative? Basically, is you directly A call B, right? This is a synchronized call. You create 2 microservices, and microservice A directly calling into microservice B. So this is kind of the user image to demonstrate. You have the browser, your end user directly open up their browser and type A's endpoint, A directly calling into B. So in more detail, so it's you send a request to A, and then forward a request to B. And B process A and send a response to A, and then return a response to the customer. So put into another use case, you are the customer and you want to check your bank details. And then you log on to your bank's homepage, and then you log in. And then it's that login microservice directly call to the backend to find out how much money do you have in your account. And then that microservice return back the response to A, find out, okay, you have £2,000 in your account, and then A response to the browser say, okay, you have $2,000 in your account. So this is a kind of synchronous call. So what I mean synchronous call means this is a blocking. So basically, if it's A calling B, B takes 2 seconds to respond. And then you can see the browser is kind of busy processing, and eventually after 2 seconds, you get a response. So this is A directly depend on B. So the process A file fired is directly being blocked by B. So this is completely, before B respond, A have to wait. And the next thing you think, okay, this is a kind of blocking, and A is kind of have to wait for B. The next thing you will think, okay, let's use the asynchronous. Basically, I have let's use more thread. You have more cores, right, in a computer. Let's use more thread to do the things. So it's what will happen then? So basically, you know, in Java, you have a future, you have a completion stage. How many of you are using completion stage? Okay, cool. So if you have not used the completion stage, after this session, you just open up your IDE, have a look at the completion stage. It has a lot method, like then apply, then accept, etc. It's allow you to change the process up. Like when is one process finished, and then the next process will be fired. So there's no process is kind of busy waiting, and then is the second process, the second thread only fired when the first one finished, and then is ready to go. So put into a kind of story, so this is if I write a letter and I ask my son to post a letter, give the letter to a post officer. So this is for the synchronous one, is ask my son, sit down here, wait for me to write a letter, and then you fetch this letter and give it to the postman. So that's a synchronized kind of thing. My son is not allowed to play anywhere, and they have to wait for me to finish a letter. The asynchronous one is that we tell my son, okay, you go and watch TV. When I finish this letter, and you go to give this letter to postman. Right? He's happy. He won't be stay there impatiently wait for me to write this letter. So this is better. However, you know, microservice is like a child. You cannot control them. Sometimes they work, sometimes they don't. Sometimes they take a long time to respond. Again, I sent my son to send this letter to postman, and then he went around to the park and forgot actually he need to give the letter to the postman, and so I need to have this contingency plan. I need to make sure the letter is going to be delivered to postman. So what do I need to do then? So I could either if my son hasn't come back within an hour, I need to send my daughter, right? And go and look for my son. Maybe he just went out to play with his other friends and etc. So luckily, in for microservices, how can I tame these kids then? How can I just make sure I can manage all the misbehavior? So we have MicroProfile Fault Tolerance. We have these annotations like timeout, fallback, circuit breaker, and etc. Bulkhead and etc. So I would like to especially mention the fallback. So fallback, basically, if you haven't got a successful response, and you can plug in alternative resolution. So this is kind of give you a different action to take. So this is very important. Thinking about when you again check your balance, check your bank account balance. You know, in the last probably 5 years ago, is normally Sunday evening, bank is at maintenance window, and then you log on to your bank. I said sorry, is we are on the maintenance window. Nowadays you don't, right? So it's one possible fix is your bank still can do the maintenance. However, it can have this fallback behavior. Basically, it doesn't need to give you on the time at this moment of time how much money do you have in your account. It can supply actually at the end of this business day you have $2,000 in your account. So this is really good enough. The other scenario is, for example, you have a Netflix account, and sometimes you subscribe to a particular movie, like a kids movie, and sometimes it's you say, oh, blinked, and then you want to do the a particular kids movie, and then he give you alternative kids movie. It's then say, okay, we cannot serve your request because I cannot stream this out. It will be able to fall back to a different alternatives. So this is potentially way thing to cope with misbehaving microservices. The other thing is let's go back to the asynchronous. When you think about if you have doing the multi-threading, one of the very popular way to do it, you directly get a thread from a fork join pull, right? Do you use multi-threading? Yeah. Once you use that thread, once you get hold of that thread, you lost everything. You don't have, it does not inherit anything from your parent thread. You know that. So this is similarly thing, like my son took the letter to go to a post office. And then I could send my daughter to look for my son. However, my daughter don't have the letter, right? It doesn't have the context. And then even if my daughter couldn't find my son, she still cannot post a letter. So what can I fix this problem? So I need to push the kind of parent context to any children threads. So luckily, in MicroProfile, we also have the MicroProfile context propagation. So with this one, with this specification, how many of you have heard of MicroProfile? Okay, cool. We are getting better. If you have not heard of it, and go to the Google MicroProfile, you will see everything. So this context propagation directly fix asynchronous losing context problem. So it creates a way to be able to capture the context and then can restore the context onto the new thread. So this is, I'm not going to the more details for this one. I just want you to think about the journey. So you can look at the MicroProfile context propagation, you find out all the APIs. So this example, here, you can directly get the thread context inject into your code, and then when you doing asynchronous programming, and you can directly say with the context captured, all the new threads going to do this operation will have all the context that have been captured, so you don't lose the context. The other thing is. How many of you know CDI? CDI? Okay, a few. So CDI, it has a lot of context. Once you do asynchronous, all the contexts get lost. It's one of the famous problem is your request context not active. So it's with this MicroProfile context propagation, the request context can push to the new thread as well. Okay, so let's go back to the asynchronous course. So asynchronous doesn't solve the non-blocking issue. Back to my story about I can send my son to do the letter posting, and then I send my daughter to do the letter posting. You thinking about this, I just got all my children occupied. They cannot do anything else. They are occupied. So literally, I blocked them. So they have to go and with the resources, right? This is not solving any non-blocking issue. So thinking about programming, when you do asynchronous, basically you use all the threading, and your thread is kind of thread pool is limited. Once you use up all the thread, you can fire all kind of the thread. Eventually, you will run out of the thread. You cannot do any other operation. Because the thing is, if you kind of long-running operation, basically all the thread are busy doing things. They are blocking. So you have not fix the problem. You just hide the problem under the copy. So what you need to do, you need to achieve non-blocking. The first thing, non-blocking, the first thing you think about is I/O. All the input output is kind of blocking. When you write to the database, when you retrieve from the database, that's blocking. So we need to solve we need to solve the blocking I/O. So you can solve you can introduce a non-blocking I/O. At the moment, there's some initiative. Hopefully, the new JDK will be able to solve this problem. It's in the reactive DBA now is being kind of folded into the new JDK. Hopefully, the new JDK will be able to, the fiber will be able to solve the non-blocking I/O. And also with the context propagation, asynchronous, and fault tolerance, you might be able to efficiently use your resources. Is that everything? What if I don't know what I'm talking about? What if I don't know who is my customer? So what if I don't know, who do I need to ask for help? This is like if I get lost in the ocean. I will not call my husband because he will not be able to help me. So the most efficient way is I raise alarm, I blow the whistle, right? And then I shine the torch. So I signal to the world, come to help me. So basically, for this kind of situation, you don't know who the receiver is. So how can I solve this problem? So the synchronous, asynchronous will not be able to solve this problem. This is why we need the reactive. So this is the kind of reactive we're trying to fix. So it's now up to now. Hopefully you understand the one thing is why do I need to care about reactive? You need to care about reactive when you do not know who your consumers are. Who are your consumers? So in this kind of scenario, you need a reactive. So what are the reactive? You have heard of the reactive. Probably you have heard of the reactive, a lot of things. Reactive programming, reactive extensions, reactive streams, reactive manifesto. Who have heard of reactive programming? Okay, cool. If you have not heard of reactive programming, probably you have used it. And Microsoft spreadsheet, that's reactive programming. Remember, if you're dealing with accounts or something, if you are a manager, you need to work out the expenses and etc. And then if you change one cell, all the affected cell automatically changed. Have you used Microsoft Excel? Yeah, spreadsheet. Yes. So that's the reactive programming. There's so many buzzwords. This is really, you feel like, okay, you need a PhD to be able to put everything right? So I'm in the next a few minutes, I'm going through all these buzzwords and hopefully connect them all so you will understand what do they mean. First thing is reactive programming. Reactive programming is a programming paradigm with the concerns of the data streams and the propagation of changes. Data streams, you're just thinking, or you push the data to some pipes, to some channels. That's data streams. So it's not particularly related to Java. It's language agnostic. So this is the reactive programming. There's implementation. Once there's kind of best practices, there's a paradigm, there will be an implementation. Reactive extension is the implementation of the reactive programming. The extensions, you have heard of the reactor? Yeah? is you have heard of the Akka and RX Java. Yeah, they are all reactive extensions. They all the implementations of the reactive programming. So they introduce stream types and also operators, how to operate these streams. Once there's so many different libraries, reactive extensions, like Akka, RX Java, like a Reactor. Once you have so many libraries, and then people will think, okay, we need a standard, right? We need a standard. Otherwise, if you change from one to the other, you have to rewrite your application. This is not good. So the same thing happened to Kubernetes now. So Kubernetes, okay, we need to a specification. All the companies interested in this area come together. We evolve together so that our end user is kind of life a lot easier because you have the standard. So this is what comes with reactive streams. So reactive streams is kind of establish a standard for the reactive extensions. So back in the 2013, so it's pivotal, and also the other Netflix and others came together and said, okay, let's all work together. Let's establish a specification to do the reactive the reactive programming. So that's evolved org.reactive streams. Do you use org.reactive streams? Anybody? Okay, not many. So this is it has 4 interfaces. It has a publisher, it has a subscriber, subscription, and processor. So it's just 4 interfaces, very simple. And also it factors in the back pressure protocol as well. Who are the implementations of the reactive streams? Again, Reactor and reactive stream, RX Java, and also Akka. So the other they came together, established a specification, and then eventually they all implemented. In this way, we as the developers, we can just import all the reactive streams, and then our application can can use RX Java, can use Akka without much change. I don't need to change my code. I can get my code running with whatever libraries I want, as long as they implement these APIs. However, the Java developers, they say, oh, I need an API. What do they mean? They want an API from JDK. So it's Oracle walked into this reactive room is quite late. And then Oracle walked into the room and said, guys, I want to establish a standard. I want define API, so you guys all follow me. So it's obviously people are not happy, reactive streams has been established since 2013. However, Oracle did an awesome job. So Oracle saying, okay, when I define this, you will be happy as well. So what they did, they adopted the org.reactive streams. So basically, it has 4 interfaces. It has a subscriber, it has a publisher, it has a subscription, it has a processor. They use, the only difference is a package name. They use java.u2.concurrency. That's the only difference. And then is the RX Java, Akka, and Reactor. They are all happy. You're awesome. We all like you. We are going to implement it. So they are all the implementers of the reactive streams for Java. So this API is available in JDK 9. So if you use JDK 9, you can freely to use this. However, one thing you need to know, in this JDK 9, it only has interface. There's no implementation. How can you use it? You use it by packaging either XJava or Akka or Reactor. So the only standardized API, no implementation. Let's have a look at these APIs. So it has a publisher. So basically, the publisher has a subscribe. So subscriber can subscribe to a publisher, and subscriber has unsubscribe and then pass in the subscription, and also has the onNext. OnNext is a callback. So publisher, with the publisher message, it will call the onNext. And then is an error. So if it's something wrong, and the publisher will call the onError, get called. And then again, onComplete is if there's no more messages to be on the stream, the onComplete will be called. And subscription is there's a request and a cancel. Cancel means I'm no longer interested in this data, so I want to cancel it. So the request, I mentioned the reactive streams has a back pressure. The request, this method, directly dealing with back pressure. So this request is very important. If I subscribe to the publisher, I say I only subscribe 10 items. I do not want 11. The publisher needs to make sure only deliver to you 10 items. You can only, this is like you go to a supermarket, right? Supermarket, you go to buy stuff. And sometimes the staff can scan very fast. You couldn't cope with the packaging, right? For a good customer service, you see, okay, you have so much piled up, it will stop, right? That's the back pressure. So there should be a policy. If there's more than 5 things you haven't packaged, it should stop. And then you feel much happier. Actually, for me, when I go to the supermarket, I want to take my daughter with me because I just feel like, it's a big hassle to package all this stuff and keep on scanning all my things piled up, give me a lot of stress. So back pressure should be applied there as well. So it's how does it work? So basically, I mentioned earlier, a subscriber can directly subscribe to the publisher, and then publisher can call back with a subscription and to the subscriber. So can create a subscriber can create a subscription and tell the publisher how many items it can cope. It will do a callback. And then is this is the third one is back pressure, representation. And when the publisher have a message to publish, it will automatically call onNext. And then if the subscriber is saying, okay, I can only cope with 2, it will only give you two things. And when the publisher has no more things to publish, it will call the onComplete. So the subscriber will no longer get anything. So also I mentioned the processor. So the processor will subscribe to the subscriber. Basically, is a kind of middleman. It is subscribed to the subscriber, and a subscriber not subscribe to the subscriber, subscribe to the publisher, and then it's kind of connected to the subscriber. So subscriber and then subscribe to the processor, processor then subscribe to the publisher. Basically, it's a middleman. It itself is a publisher, and it is also a subscriber. So how can I use Reactive to fix my problem? So if I don't know my consumers are, some consumer maybe have a different speed process. So my consumer can directly find me, right? My consumer, if I got lost in the ocean, I raise alarm. I blow the whistle, maybe the helicopter or some of the ships, and then can find me and rescue me. So this is kind of, I can do the like sending the message. And also the other example is if I'm the supermarket cashier, right? And there is a kind of, I can serve a lot of customers at the same time. And some customers can deal with the packaging very fast. So I supply different back pressure policy. And some customer very slow, again, we scan slowly. So this, I can use a different back pressure policy. I'm not directly connected with any of my customers. So my customer find me and to request items from me. To go to extreme, and one day you might consider to build a reactive systems. However, not many reactive systems available. And only under very like a few circumstances you want to build a 100% reactive systems. This is directly based on all your business requirement. Do not always try to achieve 100% reactive systems. It's quite difficult. You need a lot of thinking, you need a lot of tools to help you. So the things I want to introduce here, however, I want to stress is not for everybody. So when you build a reactive systems, you need to know the reactive manifesto. So reactive manifesto is here. Your system needs to be responsive, need to be elastic, need to be resilient. And the fourth categories need to messaging driven. So the message driven is directly plug in the synchronous message passing aspect. So the responsive is easy, and basically you can respond all the time. Resilient, again, you can use some libraries, even you can use MicroProfile Fault Tolerance to achieve that. Elastic, you can use Kubernetes like a scale up, scale down, and to achieve this elastic. For messaging, for message driven, and you need to use some help. You need some help. You need another framework to achieve that. So it's at first you need to, when you think about using messaging to achieve decoupling, this is nothing new, isn't it? We always use email. I interact with my colleagues in the US, in Canada. I send them email. I don't wait for the email to respond. I don't do anything else. I just watch my mailbox and to pop up with a response. Once I fire a message, I can carry on doing other things. When the message come back, and then I can take action. So this is kind of asynchronous and also non-blocking. So it's so for messaging, I mentioned you can use email in your daily life. However, in microservice, how can I do this messaging? Luckily, we have a MicroProfile Reactive Messaging specification to directly achieving the messaging aspect in your microservices. So how do I do it? So it actually is quite simple APIs we introduced in the MicroProfile Reactive Messaging. There's two APIs you need. One is incoming. Incoming is more like a consuming side. So I say, okay, I'm interested in this channel 1. I'm the consumer. The other one is the outgoing. So basically, it's a publisher. You publish a message to a channel, to the channel 1. So in this scenario, these two microservices, they do not know each other. They don't need to know each other. They just a particular subscribe to a particular channel. And in this case, the publisher can directly send a message to the consumer. Actually, the publisher send a message somewhere, and the consumer retrieve a message from somewhere. So the somewhere is a channel. So they communicate via that channel. They don't know each other. They don't even know where the the publisher lives. I don't need to know the URL at all. I do not know the URL for this consumer at all. So the consumer can go at any time. The publisher can go at any time. Maybe it goes, another publisher come in to publish a message. The other thing is, when I mentioned the publish somewhere, where is this somewhere? The somewhere could be Kafka. It could be the Kafka stream, or could be MQTT, or could be MQ. So this is, we call it a connector. So it's basically you can configure and say, okay, you publish to a Kafka topic, or you publish to MQTT. And as long as the consumer can also subscribe to that place, you are fine. The message will be delivered from the publisher to the consumer. So this is demonstrate how it works. So basically, they connect it via the connector, via the streams. So with this kind of reactive architecture, so we achieve the decoupling. So because the publisher doesn't know the consumer, and also the elastic. So I can have as many consumer as I want. And also resilience. Once you publish a message to the Kafka topic, your message is safe. And also the backup pressure, so you can say, okay, I only consume these messages and etc. And again, also it's synchronized. Basically, the consumer can go and then later on come back to directly consume the message. And then this is truly non-blocking. So my publisher doesn't need to know my consumer, and it can go ahead to publish messages. And the consumer is coming back and then consume message, and then later on goes, and then later on come back. It doesn't matter. So non-blocking. With that, I want to give you a quick demo. In this demo, I have two microservices. And they don't know each other, and they service A directly. Oh, okay, cool. Service A directly published is a producer. Service B is a consumer. So service A haven't got any clue where service B lives. Service B doesn't know anything about service A. So service A published a message to the Kafka, and service B subscribe to that Kafka topic. So in this one, so this is I already have that. So that's the code, service A. So you can see this service is a producer. Can you see it? Okay. So the producer, so it's the kind of producer to a channel initial prices. So directly generate some random numbers. So the generating price. So now I can start a service A. Service A is running on Liberty. I start a service A. So that's a publisher. And then at the same time, this is service B. Service B is a consumer. So the consumer, again, it just say at incoming prices. So it's basically directly consume this consume the message from the channel, the prices. Let me start the consumer. So you can see publisher is publishing message, and then consumer, the consumer come back, and then it's directed to consume the message. You can see I started quite early, the publisher. The first one is 329, and later on I started the consumer, and it still get the 329, right? So it's you might be thinking, okay, how did it work? How did they get connected? How can the service A get the message, or how can the service B get a message from service A? And you might already have noticed right here. This says prices, right? However, in my code, the service A, it says initial prices. Why did I do that? Because I want to demonstrate service A have nothing to do with service B. If I have to use exactly same channel, this defeats the purpose. They are deep coupled, right? I don't even know who created this publisher. How do I know which channel they connected to? So how can they connect it? There's a magic here. So this is a kind of this channel at initial prices. So it's communicated via Kafka. So it's you can see I will just say here initial prices. I said okay, is a Liberty Kafka, and then I specify actually I connect to the topic 1, and then where does my Kafka lives? My Kafka a server. Do you know Kafka? Anybody know Kafka? Okay, so this you probably will know this one. So you know the Kafka bootstrap server. So my server is in my IBM cloud. So this, so a lot of broker in here. And then the protocol I use is the Transport Layer Security version 1.2, and also the security protocol. And this is very important. Topic 1. Let's have a look. Topic 1, and this is by bootstrap server. And in my service B, in my service B, the channel I use is prices. I just say mp.messaging.incoming.prices. Again, I use the Liberty Kafka. The topic I'm interested is topic 1. And then the Kafka server, I directly use the exactly same Kafka server. And then a protocol and as security protocol, I use the SSL, or you could use plain. And also this is the configuration. I use the username and password type to do the configuration. Now has it clicked? So basically, my producer connected to the Kafka server, connect to a particular topic or Kafka server, and publish message to that. And then my consumer is also connected to the Kafka server to that topic. So that's why it got all the messages from my publisher. So my publisher have nothing to do with my consumer. So now I show you where is my Kafka. My Kafka is directly in my IBM cloud account. So you will know in that Kafka stream I have a topic 1. Let's have a look. So this is my this is my, see? That's what I declared. So basically the producer directly published to the Kafka server. That Kafka server lives in my IBM Cloud account in the cluster and publish a message to the topic 1. And then my consumer also subscribe to the topic 1. That's why it got message. And all the big blob I used is directly copied from here. Yeah? You can see, so this is my Kafka server. This is this is the protocol. Yeah, this is the SSL like protocol transport layer version 1.2. And this is the token and the password. I can work out my password in the service credentials. You can view. So this is my password. So it's basically this is how is decoupled between the publisher and the consumer. Is directly you connect to the third party like a broker. So you all communicate to the broker, and then you can get a message delivered. So with that, I think we'll open for questions. Are there any questions? Yes?
Well, is there any kind of type safetiness between the publisher and the consumer in terms of the message? Because now you were declaring an integer message.
Yes.
But what happens if the message received is not an integer? So I mean, is there any kind of contracting or anything?
Yeah, very good question. Yes, that type. The type needs to be the same.
Okay.
Yeah. So it's you need to serialize it and etc. The type needs the same.
Okay.
Yeah. Thank you.